whatever the source available with you now, you make use of that one and practice more and more numericals. Okay, so numericals are very very important, and that will give some work to your logic mind. Okay, so we'll solve few more examples, numericals. So we'll go with the next question. What is that? Two railway tracks are parallel to north-south direction. Oh, one is in north direction, other is in south direction. So train A is moving with a speed of 40 meters per second north to south. Okay. Suppose if I take this as north and this as south, train A is moving from north to south with a velocity of VA equals to 40 meters per second. Okay. So while train B is moving with a speed of 30 meters per second from south to north. Okay. So train B is moving from south to north. So velocity of this is, say, what is 30 meters per second. Okay. So what we are asking, relative velocity of B with respect to A, relative velocity of ground with respect to A. Yeah. So first you write, what is velocity of A? Velocity of A is 40 meters per second. Velocity of B is 30 meters per second, but what I will do is I will take it as negative. Okay, so because if one you are taking positive in this north to south, so obviously south to north you can take it as negative, or if you are taking this as negative, you can take this as positive. So whenever there is opposite, you can directly write VA plus VB also, but why to go with a different problem? So remember, whenever opposite direction, one you have to take negative, another you have to take positive. Okay. So relative, first one is what? Relative velocity. Relative velocity of B with respect to A. Relative velocity of B with respect to A. What you can write? Relative velocity of B with respect to A, you can write as VB minus VA. What is VB? VB is minus 30. What is VA? VA is 40. So minus of 40. So what you will get? Minus 70. Minus 70. Remember negative. So VBA is minus 70 meter per second. So what exactly its meaning? Train B moving with a speed of 70 meter per second with respect to what? With respect to train A I am not taking negative here, so I will mention the direction in the direction from where to where? From south to north. Okay, from south to north. Okay, so this is what the solution of first one. So what is second one? Second one, they are asking a relative velocity of ground with respect to A. So what is the velocity of ground? Velocity of ground, I will take it as Vg. So velocity of ground. So ground velocity. So ground velocity Vg is what? 0. Ground is not moving, so it is 0. So it is 0. What you have to find? You have to find relative velocity. What they are asking? Relative velocity of ground with respect to A. So what you can write? VGA, relative velocity of ground with respect to A. So Vg minus Va. What is Vg? Vg is 0. And what is Va? Va is what? Va is plus 40. So plus 40. So answer is coming what? Answer is coming minus 40 meter per second. What it means? Minus 40 meter per second means the ground is moving with 40 meter per second opposite to A. Means if you are moving in the train, so ground looks like moving in opposite direction. So that is why you are getting what? You are getting negative. Okay. So ground seems to move from what? From south to north. If A is moving from north to south, ground moves from south to north. So that is why you are getting negative. Okay, that is what the meaning of negative sign. Okay, so you must express this when you move in the train or something. So when you are moving in the vehicle, so ground looks like moving in the opposite direction. Okay, so this is what the first question. Okay, next question. I hope this is from your NCERT text. I think example number 3.5. Okay, so a jet aeroplane traveling at a speed of 500 km per hour ejects its products of combustion at the speed of 1500 km per hour relative to jet plane. This 1500 is what relative to jet aeroplane. So jet plane. What is the speed of latter? Speed of latter is speed of jet plane with respect to an observer on the ground. With respect to an observer on the ground. Okay. So now, suppose your jet plane is moving in upward direction with a speed of, say, velocity of jet, we will take it as 500 km per second. So here downward, what will happen? Combustion is there. So it is moving in this direction, opposite direction. So combustion VC. Okay. So VC, I will take it as what is this? This is 1500. They are not given VC. They are not given velocity of combustion. They are given velocity of combustion relative to Z. It means relative to J. So you cannot write this as VC. You have to write velocity of combustion with respect to Z, not with respect to ground. Then what exactly you have to find? You have to find velocity of combustion. Vj is there, Vc don't know, but Vc with respect to J you know. Velocity of combustion with respect to jet you know 1500, and velocity of jet you know, but velocity of combustion you don't know. That means what exactly its velocity. A person or observer standing on the ground, he sees the velocity of combustion not with respect to jet, he will see as its original velocity. So that we have to calculate. That is what velocity of combustion. Okay, so both are in opposite direction. So if you take this as positive, so upward you have to take what was negative. So VCJ is how much? VCJ is 1500. Okay, so VJ is what? 500. So this is what? Kilometer per hour and kilometer per second. So kilometer per second or kilometer per hour? Kilometer per hour. Okay. So 1500 kilometer per hour, and this is also kilometer per hour. Okay. So both are opposite means can we write it as what? Velocity of, better we can take this one as negative. If you take downward as positive, we have to take upward as negative. Okay, so if you take upward as negative, or simply directly you can, if both are opposite, so we can directly write Vcj equals to velocity of C plus velocity of J. This we have discussed also. Okay, when two are in opposite, directly you can write Vc plus Vj, or you can take one as negative. So anyone you can take negative, and you can use as usually Vc minus Vj also. So both are correct. Okay, don't get confused. In last problem I used that method, so here I will use this method. Okay, same method also you can use. So just to know that both are possible, so I am using this one. So what is this? 1500. So Vc we don't know, so plus 500. Okay, so Vc equals to, bring this 500 on this side, so 1000 minus 500. So Vc is, so 1500 minus 500, so it will become 1000 kilometer per hour. Okay, so this is what velocity of combustion with respect to an observer on the ground. Okay, so this is what how you can get the solution for this one. So next question: a body starts from rest and acquires velocity of 12 meter per second in 5 seconds. So first you have to write whatever given. What is that? Body start from rest means initial velocity. Initial velocity means starting from rest means what? U equals to 0. Acquires a velocity of 12 meter per second. So final velocity. Final velocity. Okay. So final velocity V equals to 12 meter per second in 5 seconds. So time taken is what? Time taken t equals to 5. These are what like your high school problems. So calculate acceleration and distance. They are asking acceleration and distance s. Okay, simple. So first one you can apply v equals to u plus 80. So v is what? V is something 12 equals to u is 0. A into time is 5. So acceleration is what? 12 divided by 5. Okay, so 12 by 5, how much? 2.4 meter per second square. Very important unit, meter per second square. Okay, so next is what they are asking? Distance. So apply your second. S equals to ut plus half at square. So yes, u is what? 0. So time will also become 0. Don't worry about this thing. This will become 0. So 1 by 2. Acceleration, don't take 2.4, that will make your calculation complicated. So take 12.5, 12 by 5 into time is what? 5 the square. Okay, so s equals to, this is to 0, don't worry about this one. 1 5 and 1 5 will get cancelled. So what remains is 2 1s are 2, 6. So 6 into 5. Okay, so s equals to 6 into 5 is 30 meter. They are asking distance, so distance is what? 30 meter. Okay, so acceleration is 2.4 meter per second square and distance traveled is 30 meter. Next question. Two trains A and B of length 300 meter each are moving on two parallel tracks with a uniform speed of 54 km per hour in the same direction with A ahead of B. The driver of B decides to overtake A and accelerates by 2 meter per second square. If after 25 seconds the guard of B just brushes past the driver of A, what was the original distance between them? So very important question. A similar question will be there in your NCERT exercise also. So see roughly what exactly they have given. Okay, there are two trains. There are two parallel tracks. Okay, so one track is here, another track is here. Okay, so two trains of length 300 meter. So trains A and B, but A is ahead of B. Okay, so this is what? Train A. So length is what? 300 meter. Here is what? Train B. Length is what? Again 300 meter. Okay. So now what will happen? Driver B decides to overtake A and accelerates by 2 meter per second. So he start accelerating by 2 meter per second. Okay. So when he accelerates 2 meter per second for 25 seconds, at that time what will happen? So after in 25 seconds, what will happen? This A may comes here. This A may comes here. And the length is what? 300 meter. No need to worry about that one. B will be what? The guard of B just brushes the driver. Means at the end of your train there will be a guard. Okay, that means end of B. End of B passes the driver of A. So this is what? B. After what? After 25 seconds. Okay. After 25 seconds. Okay. So this is what they have given. What they are asking is they are asking what was the original distance. This was the original distance. Okay. So from here to here, you can take it as S0. Original distance you can take it as S0. Now in 25 seconds, so A will travel this much distance. So how much distance it will travel? It will travel this much distance. You can take it as SA or okay, SA you can take it as. It is not till here. It will be what? Till this point, end to end, from here to here. SA. Okay, this is what SA. What about SB? SB we have to take SB from here to, so this is what SB, so from here to here, okay, so till this point, okay. So now see here, this SB is equals to S naught, this SB, this total distance is equals to S naught plus this 300 length of train, then SA from here to here plus this 300. I hope you are getting. This total SB is what? From here to here is S naught plus length of this train, then from here to here SA means distance travelled by A, then from here to here is what? Again 300 meters. So what equation I can write is SB is equals to S naught plus 300, this 300 plus SA plus 300. Okay, so this equation is going to give you what answer. Okay, so try to observe this properly. So try to observe that properly. Here only you can get the what solution. If you do not understand this one, so it will be difficult. Okay, so now I will solve the problem. First we have to find what is the velocity of or speed of train. So speed of trains. So what is that? P equals to 54 kilometer per hour. So convert into meter per second. Okay, so we can convert 54 meter per second is 1000 divided by 3600. Okay, means 60 into 60 if you want to write it properly. Okay, this zero will get cancelled. So 9 and this is what 2 3. Okay, so that means 30 by 2, that means what? 15. So 15 meter per second. 15 meter per second is what? Velocity of the trains. Okay, now first to calculate S naught, so we don't know. SA you can calculate. Okay, so SA you can calculate as VA into time taken, because velocity is what? Distance divided by time. It is not accelerating, it is moving with constant velocity. That is why you can use this formula. Otherwise you have to use what? You have to use the acceleration, V equals to U plus AT. Okay, so now, so what you can write, SA is equals to VA is what? VA is 15 and this is what? 25. Okay, 15 and 25. So how much you will get? 250 plus 125 means 375 meter. Okay, 375 meter. So this is what velocity distance traveled by train A. Okay, distance covered by train A. Now distance covered by B is, so what it is? SB is equals to, so here you have to apply what? UT plus half AT square. Why? Because they are saying he is accelerating. He was not accelerating, velocity was constant, so you can use this. So here he is accelerating, so try to use this formula. So what is U? U is 15 and is 25 plus 1 by 2. Acceleration is what? Acceleration is 2. Okay, 2 meter per second square. We have written here. So 2 into T. T is what? 25. Half AT square. So 25 the square. Okay. So this two will get cancelled. So 50 into 25 is what? 375 plus 25 the square. How much will you get? 625. 625 plus 75 will become how much? 700 and this 300. So it will become a total 1000. Okay. So 1000 meter. SB is what? 1000 meter. Okay. So now use that to find original distance. To find original distance between trains A and B. So what you have to use this one. SB equals to SA plus 300 plus S0 plus 300 plus SA plus 300. So SB is what? SB is 1000 equals to S0 we don't know, so plus what is this? 300 plus what is SA? SA is 375. Okay, so 375 plus 300. So total 1000 equals to S0 plus 600. So how much it is? 600. So 900. So 975. 975. So S0 equals to take this 975 on this side, will become negative. So 1000 minus 975. So S0 will become what? 25 meter. Okay. So the original distance between the trains. This is what? This is 25 meter. This is what they are asking. Okay. So try to understand this problem properly. So same problem is there in the NCERT. You go through that one. So one more simple problem. A brake is applied to a car traveling at a rate of 30 meters per second. So there is a car. So it is going with 30 meters per second. Its velocity is reduced to 20 meters per second in 5 seconds. Okay. So when brake is applied, so its velocity obviously decreases. So it will become what? It will become 20 meters per second. Okay. So how much time it has taken? Time taken is 5 seconds. Calculate retardation produced by the brake. So retardation you have to calculate, acceleration A. Also calculate the distance covered in those 5 seconds. So this distance you have to calculate. You can call it as stopping distance also. It is not stopping actually, but we can call. So yes, they are asking. Okay. So this is what initial velocity U and this is what final velocity V. So first we have to find what retardation. Okay. So to find retardation. So to find retardation, apply V equals to U plus 80. Okay. P is what? P is 20. So U is what? U is 30 plus A is what? Maximum retardation. So time taken is what? Time taken is 5. Okay, so 30 comes on this side, it will become minus. So 20 minus 30 equals to A into 5. So A equals to 20 minus 30 will become minus 10. So 5 will come here. So minus 2 meter per second square. Retardation is minus 2 meter per second square. So they are asking distance covered in those 5 seconds. So distance. So to find distance, what you can apply? Can apply S equals to UT plus half 80 square. So S equals to U is what? U is 30. So 30 into time is what? Time is 5 plus 1 by 2 into acceleration is minus 2. So take it as minus 2 and T the square. So 5 the square. We have to take minus, so don't forget that. So 30 into 5 is 150. Plus this 2 will get cancelled, so negative and positive will become negative. So 5 is what? 25. That's all. So 25. So what you will get? S equals to 150 minus 25 will become 125 meters. So it is traveling around 125 meters. So this is what the distance covered, 125 meters. So acceleration is what? Acceleration is minus 2 means or retardation is 2 meter per second square. So next question, a body moving with uniform acceleration describes 20 meter in second and 30 meter in fourth second of its motion. Calculate the distance moved in 6th second. Okay, so let's see. What is the distance traveled in 8th second? Sn equals to U plus A by 2 into 2n minus 1. 2n minus 1 or n minus 1? 2n minus 1. Okay. So U plus A by 2 into 2n minus 1. This is what the equation. What they are saying is S2 is 20. S4 is 30. means n equals to 2 here, n equals to 4. Okay. So what they are asking for S6, that is n equals to 6. Simple. So interesting question. So S2, I will write it as S2 equals to, see here, if you want to calculate S6, what is required? U plus A by 2 to n minus 1. N you know 6. A is required, U is required. A is required and U is required, but both are not given. So you have to, with the help of these two, you have to calculate A and U. Okay. So what I will write it as S2 equals to, so U plus A by 2 into 2n. So 2n minus 1. So S2 is what? S2 is 20. 20 equals to U plus A by 2. 2 into n is 2 minus 1. So what we will get is 20 equals to U plus 2 2s are 4, 4 minus 1 3. So 3 by 2a. So this is what equation number 1. Similarly write for S4. So S4 is equals to again U plus A by 2 into 4 minus 1. Okay, actually here n equals to what it is 2. So S4 is what? 40, 30. So 30 equals to, so U plus 2 4s are 8, 8 minus 1 is 7, 7 by 2, 8. So this is what equation number 2. So solve these two, you will get what you will get? You will get U and A. So what I will do, I will subtract 1 into equation 2 minus 1. So 30 minus 20 is what? 10. So U minus U is 0. So plus 7 by 2A minus 3 by 2A. 7 by 2A minus 3 by 2A. So 10 equals to what you will get? 7 by 2A minus 3 by 2A means 4 by 2A. So 10 equals to 2A. So A equals to what? A equals to 5. So you got A as 5. Okay. So if you got A as 5, so substitute here in this equation. So we can calculate U. 20 equals to U plus 3 by 2 into 5. Okay. So 20 equals to U plus 15 by 2. So U equals to 20 minus 15 by 2. So 40 minus 15. So 25 by 2. That's all. Okay. 22 is a 40. 40 minus 15. Okay. 25 by 2 meters per second. Okay. So you got acceleration and you got its velocity U as well. So U you got 25 by 2 and A as 5 meter per second square. So now what we want? We want distance moved in 6 seconds. Okay, yes, 6. For this A is what? A we got 5 and U we got 25 by 2. 25 by 2. Okay. So S6 equals to what is U? U is 25 by 2 plus A is what? 5. 5 by 2. 2 into N is what? N is 6. 6 minus 1. Okay. So S6 equals to 25 by 2 plus 5 by 2. So 6 2s are 12. 12 minus 1 is what? 11. So 25 by 2 minus plus 11 5 is 55. So 55 by 2. So what will we get? We will get it as 25 plus 25 plus 55. Okay, so this will become 60 80. So 80 divided by 2. So that is what? 40 meter. Okay, so distance traveled in 6 seconds is what? It is 40 meter. Okay, so answer is what? Answer is 40 meter. Okay, so this is what how we can solve. A very good example. Practice it, you will get it. Okay. So next question, again I think based on relative velocity. Two trains T1 and T2 are running on two parallel tracks. So T1 moves with a speed of 40 km per hour. So VT, velocity of train T1 is 40 km per hour. So in east direction. Okay, so you take this as east and you take this as west. So T1 is moving in east direction, and T2 is moving 60 km per hour. T2 is what? 60 km per hour, but it is moving in due west direction. Okay, so it is moving in west direction. Okay, so what they are asking, calculate the velocity of train T1 with respect to train T2. Okay, so first you have to take the sign conventions. So T1 from west to east. Okay, so in east, in due east means I will take this as positive, so 40 km per hour, and T2 I will take it as negative. So T2 I will take it as negative, that is what? Minus 60 km per hour. So first one is the velocity of train T1 with respect to T2. T1 with respect to T2. So what you can write? Velocity of T1 with respect to T2 is what? T1 minus T2. T1 with respect to T2. T1 is what? 40 minus of minus 60. So this will become minus plus. So this will become 100 km per hour. So train T1 seems to be moving with 100 km per hour with respect to T2. Okay. So now second one, this is coming positive, means what is the direction? In east direction. Okay, in east direction. Next is velocity of T2 with respect to T1. So T2 T1 is V of T2 minus V of T1. V of T2 is what? Minus 60. V of T1 is 40. So minus 60 minus 40 will become minus 100. So 100 km per hour. So in what direction? In opposite direction, west. So negative means opposite, positive means forward. Means positive means in east and negative means in west. Okay. So velocity of ground with respect to T1. What is the velocity of ground? Ground with respect to T1. Okay. So velocity of ground Vg is what? Vg is 0. So velocity of ground with respect to T1 is V ground minus Vt1. So V ground is 0 minus Vt1. Vt1 is 40. So minus 40 meter per second. That means if T1 is moving in west east direction with the speed of 14 km per second. So see ground with what they are asking, ground with respect to 10. So ground looks like moving with 40 km per second in the opposite direction. This means in west direction. Okay. So these are the few examples. So many examples are there we will solve, and you also practice more and more examples, because numericals are very important in your physics, and they are very important for your mind also. That will make your logical mind